Today we will discuss about effective mass of electron. We write it by m star. First of all, we will see what is the physical meaning of effective mass. We know that an electron has a well-defined mass, and when accelerated by an electric field, it obeys Newtonian mechanics. So it is clear to all. Now, suppose we consider the case when the electron is inside a crystal. Actually, the electron in a crystal interacts with crystal lattice. As a result, when an external electric field is applied, the electric field will see that the electron inside the crystal is not free, but it is in interaction with crystal lattice. So there must be a deviation in the behavior of the electron in the crystal lattice from the free electron behavior, and this matter can be accounted simply by considering electron to have an effective mass m star rather than its free mass m. The effective mass m star depends on the nature of the crystal. So today we will first find the expression for m star. Okay. According to de Broglie, an electron moving in a crystal may be considered as wave packet. The group velocity associated with that wave packet is Vg, represented by Vg, and it can be shown that this group velocity is equal to the particle velocity. So the acceleration of the electron inside the crystal may be represented by A is equal to dVg dt, where Vg is the group velocity. So you can write this as dVg dk into dk dt. So we have obtained two terms, one is dVg dk and another is dk dt. To find the expression for acceleration, you need both dVg dk term and dk dt term. Now, what is Vj? That is group velocity. According to de Broglie, this group velocity may be equal to d omega dk, and we know omega is 2 pi nu, so 2 pi you can write this as d nu dk. Okay, and further you can write this 2 pi by h de dk. Why? Because we know E equal to h nu. Clear? So E equal to h nu, and so it is 2 pi by h de dk, and h by 2 pi is written as h line in quantum mechanics, so it can be written as 1 by h cut de dk. Therefore we can write dVg dk equal to 1 by each line d2e dk square. Give it number 2. So the two term we have desired, that is dvg dk and dk dt, we have found out the value dvg dk, which is this. Now we are interested to find dk dt. In order to find dk dt, we consider the situation that an external electric field is applied to an electron inside a crystal. So due to this applied electric field, it will displaced from its position, and it acquires some energy due to work done, and that energy gained can be written as dE is equal to, it is force into displacement. This is the work done, it is the change in energy. Force is minus E because electron is negatively charged, minus E dx. So we can write minus EE and dx, since Vg equal to dx dt, so we can write dx equal to Vg dt. Vg is the group velocity, which is exactly equal to the particle velocity, that is electron velocity. So we can write minus EE Vg dt equal to minus E. What we have obtained Vg, what is the expression for Vg? It is 1 by h cut dE dk. So put that value, 1 by h cut dE dk into dt. So this equal to minus E by h cut dE equal to minus E by h cut dE dk into dt. Therefore we can write dk by adjusting this relation on both sides. Dk is equal to minus EE by h cut into dt. Therefore dk dt will come out as minus E by h cut. So we have give it number 3. So what we have desired, dvg dk and dk dt, we have obtained dvg dk and now obtained dk dt. So putting the values from 2 and 3 in relation 1, we can find the expression for A, expression for acceleration A. Therefore relation 1 implies A is equal to dvg dk into dk dt, putting the values 1 by h cut d2e dk2 into E by h cut with a negative sign. So you can write minus E by h cut square by d2e dk2 and you can write this as minus E by m star. You see, it is the expression for force on an electron in electric field. Force by, this is mass, that is acceleration. Therefore, this quantity is playing the role of mass on an electron moving inside a crystal, and we designed it as m star. So we can write m star is equal to h cut square by d2e dk2. This is the well-known expression for effective mass of electron. You see that m star, the value of m star, h cut square is constant, value of m star depends on d2e dk2. That is, value of m star depends on the nature of d2e dk2 term. So if graphically we have to study this, then first of all we have to draw EK curve for electron inside a crystal. Then from that EK curve we will draw DE decay curve, and next from DE decay concept we will get the concept of D2E dk2, and finding the values of D2E dk2 we will see somewhere this is positive and somewhere it is negative, and that's why in some cases m star becomes positive and some cases m star becomes negative when an electron is confined in a crystal lattice within according to band theory. So in the next class we will find the nature of m star, when it becomes positive and when it becomes negative, along with the discussion of the graphical presentation with this study.